First, thank you for introducing me, Dr. Fuller, and nice to meet you all. My name is Seungbum Hong from National Institute of Ecology in Korea. We are sorry for having this conference through computer screens, though. I hope you guys all are safe to the virus forever. By the way, my apology is that I may need to leave sometime after my talk because I'm having another conference right now. There is an on-site conference in Korea, so please understand my situation. So if you get some questions about my study and if we have no time to communicate for that, please feel free to contact me through email later. And also, actually, I'm not professional in birds and even in ecology. I'm doing with the modeling things related to climate change. So, well, you will probably see like awkward expressions from me and so on. And I'm like an amateur in this field, so please understand this too. Okay, now what I'm trying to talk about this time is about climate change risk assessment for flat-tidal marshes in Korea, which are famous for shorebirds stopover sites. This slide shows the hot places for shorebird migration stopover. In Korea, the habitats are mainly located in the west seashore flat-tidal marshes. The upper picture in the right-hand side in this slide shows our beautiful nature related to the shorebirds we love, but the picture below shows also our selfish nature threatening our birds. Okay, you guys all may know this session is supposed to deal with climate change impact, so I may need to mention briefly about climate change first. As you may know, international efforts for coping with the climate change impact have increased more and more. You may be already familiar with IPCC, which is a kind of council to help policymakers with scientific information about climate change. Scientists in IPCC generally agree to climate change adaptation now is not an option, but indispensable. Well, my institute, NIE, and I are interested in terrestrial ecosystem, and according to the recent IPCC report, the climate change impact on our terrestrial ecosystem will be substantially high. So as IPCC scientists have suggested, we need to do something for our ecosystem, preparing something for future impact. Of course, the climate change impacts on our terrestrial ecosystem will definitely affect biodiversity. There is a similar panel as IPCC, but for conserving global biodiversity, IPBES. IPBES tells us that there may be the sixth mass species extinction at the end of 21st century, and one of the major threats is climate change. In order to do something for our ecosystem against climate change impacts, first we need to know what will happen in our ecosystem, and we need to find out which problem will be at high risk so that we can do something urgently on it to reduce the risk. To diagnose or assess climate change risk for ecosystem, we need to define what is climate change risk first. As in this slide, Wikipedia provides each definition like shown in this slide, but I want to focus only on the word loss. This word is a kind of economical term, so to prevent the loss, following efforts should be, of course, related to human and human lives. In this point of view, risk management for the ecosystem field should be directing to ecosystem services, but we are far behind to assess climate change impact on ecosystem services, and still we need to know what will happen to our wildlife, habitats, and their systems, such as food chains, competition, and symbiosis. Those are ecological laws, and they are essential factors to quantify loss of our ecosystem services due to climate change impact. So in this study, we defined climate change risk for ecosystem only targeting the ecological loss, not for loss of ecosystem services yet. So now, In terms of climate change risk, we try to assess climate change impact on the food chain relationships related to shorebirds in Korea. We have assessed many risks such as expansion of alien species, extreme drought event, increasing soil moisture deficit, and so on. But one of the risks we have worked, I'd like to show you the one related to shorebird and their habitats. To assess the climate change risk for the shorebirds, we have set up three simple steps as shown in this slide. First step is food source risk reduction for shorebirds that are invertebrates living flat-tidal marshes. We diagnose how many species will be threatened due to rapid warming speed. The next step is habitat reduction due to sea level rise. Because we are focusing on shorebirds, the habitats were diagnosed related to interruptions for their feeding activities due to permanent flooding by sea level rise. The last step is to combine this assessment result with actual bird observation data. For this assessment, we collected data as shown in this slide. For example, shorebird visiting data. They stop over Korea in spring during their northward journey and visit once again in fall during their southward journey, as you may know. And other data set we collected are spatial distributions of flat tidal marshes and species survey data of invertebrates. From now, I'll introduce how we assessed the risk for each step and the result. First, a risk about species unable to track climate change space. This is nothing but we try to find out how many species and how fast will face unfavorable temperature zones. Because of warming, some species will be in danger of disappearing in Korea. We developed a simple method for this, borrowing the concept of IPCC, which is about the analysis of causality between temperature increasing speed and mobile capacities of species. According to the prediction, the temperature in Korea will increase about 6 degrees Celsius based on the RCP 8.5 climate change scenario, which is the worst scenario. And actually, current climate changes are following the track of the worst scenario. On the other hand, we assess the climate change risk based on the optimistic scenario, RCP 4.5 too. In the right-hand side in this slide, you can see the assessment results indicating that in the invertebrates in the flat tidal marshes are not much sensitive to temperature changes, which means, fortunately, warming speed may not be a matter of the food availabilities for our shorebirds. The next step is related to the impact of sea level rise. We have collected cross-sectional geomorphological information for each marsh and calculated the distance of flooded due to sea level rise, applying predicted rising speed. And then we combine this habitat reduction information with biodiversity of invertebrates. Sea level rise in the west seashores in Korea has been predicted to rise up to 63 and 83 centimeters until 2100 based on 4.5 and 8.5 scenarios respectively. And the impact of those sea level rise will probably be significant. Maybe more than half of our flat tidal marshes will be under habitat reduction problem. The last step is to apply the assessment result I have shown previously with actual shorebird visiting sites. But unfortunately, we could not finalize this assessment in this last step because of geographical mismatches between bird and the data sets. For example, for some places, we have got shorebird observation data, but geomorphological information and invertebrate species data are not available, or vice versa. So only we could assess the risk for 4 sites as shown in this table. The first reason is one of the hot places for shorebirds visiting, Yubu Island. where it's very close to National Institute of Ecology. On the other hand, the flat marsh in Yeongjong Island shows medium risk. That marsh is located in north part in South Korea, and the huge international airport is located near there. Well, we are not satisfied the result yet. So as future work, we are trying to extract more detailed geomorphological information, not just with cross-sectional structure using satellite information like shown in this slide. We are extracting accurate two-dimensional habitat reduction information. We do not want to miss any important place to assess this risk. Then we definitely need to collect more data such as bird observation, their food source availabilities, and in addition, we if we could get some information about their feeding behaviors, like how many food they need to maintain their good health condition for their long journey, something like that. Well, so this was my last page for my talk, and thank you for your attention.